Welcome to Physics and Rapid YouTube channel. In today's video, I'm going to continue doing EMT, that is electromagnetic theory. In the past two videos, I have done the basic mathematics that is required for EMT. In today's video, I have started with the basic or the first concept called Coulomb's force or Coulomb's law. Okay, now what is this Coulomb's force or Coulomb's law? Let us try to understand this. Now, what is the statement? Before going to the statement, we shall study about the point charges. Okay, what are these point charges? So, the point charges are nothing but if we consider 2 point charges, that is Q1 and let us consider Q2. Okay, Q1 and Q2 are the point charges. The distance between the point charges, I am calling it as R. It is separated by a distance R. So what I mean to tell is the distance is very large when compared to the size of the charges. Those charges we call it as point charges. I am repeating again. The distance between the charges are quite larger when compared to the size of the charges. Those charges are nothing but the point charges. Like that, we are considering such charges, that is I am considering that is Q1 and Q2 be the two charges such that the force of attraction or repulsion between these two charges is directly proportional to the product of magnitude of the charges and the force of attraction or the repulsion is inversely proportional to the square of the distance between them. I have considered the distance between them to be, or the separation between them to be R. So force is directly proportional to the product of the magnitude of the charges, that is Q1 and Q2, and force is inversely proportional to the square of the distance between them. And this is the statement of Coulomb's force or Coulomb's law. Okay, now on combining this both equation, I can write it as force is directly proportional to, I'm neglecting this only magnitude term, Q1 Q2 divided by R square. Now we must remove this proportionality constant, right? If I remove this proportionality constant, a constant will arise. That constant I am calling it as K into Q1 Q2 divided by R square. Now what is this K? What is the value of K? The K value is given by 1 divided by 4 pi epsilon naught. Okay, where epsilon naught is the permittivity of free space. Permittivity of free space. Okay, so on replacing the value of K, we got a force to be equal to 1 divided by 4 pi epsilon naught Q1 Q2 divided by R square. Okay, so this is the value of force in terms of magnitude only. So in terms of magnitude, the value of force is F, which is equal to 1 divided by 4 pi epsilon naught Q1 Q2 divided by R square. Okay, now I want in terms of vector form, means F vector can be written as 1 divided by 4 pi epsilon naught Q1 Q2 divided by R square into R cap. This R cap represents a unit vector along the direction. It represents the direction of this force. This part represents the magnitude, whereas R cap represents the direction. The direction is along the point charges. Okay, I hope everyone is clear. Now this R cap, this unit vector, I can write it as one more way. R cap, which is equal to R vector divided by magnitude of R, I can write. So this equation implies now F vector can also be written as 1 divided by 4 pi epsilon naught Q1 Q2 divided by R square. Instead of R cap, I can write it as r vector divided by magnitude of r vector. Magnitude of r vector is nothing but r, so it will be r to the power of 3. So you can write this way also, you can write a before way also. So these are the equations for Coulomb's force. So I hope everyone is clear about the statement, right? Now we have properties for this charges. Charges like charges attract if I consider QQ. So this like charges will repulse, and the unlike charges like Q and minus Q. So the unlike charges will attract, the like charges will repel. Like that we have a properties. So this is one of the property that I am requiring, that I am explaining only. So remember one thing, like charges repel, whereas unlike charges attract each other. So let us move on to the next question, next concept called superposition principle. What is the superposition principle means? If I consider a charges in a space or a plane, I can call it as x, y, z plane only. If I'm having a charges that is q1, q2 and q3. So I'm considering a one more charge that is a point charge q0. So I want to find a force on this q0 because of all these three charges. I want to find force on q0 because of q1. I want to find force on q2, where q0 because of q2. I want to find force on q0 because of q3. So how to find this can be find out as the force on q0, which is equal to, if I consider the forces between q1 and q0 to be f1, the forces between q2 and q0 will be f2, and the forces between q3 and q0 will be f3. So a force on q0, which is nothing but the vectorial sum of f1 vector plus f2 vector plus f3 vector. Like on simplification, I can write what is the value for force. Force which is equal to 1 divided by 4 pi epsilon naught q1 q2 divided by the distance between them. So the distance between q1 and r1, q1 and q0 if I consider to be r1. So the distance between these two if I consider to be r2, and this distance between these two if I consider r3, then it will be, which is equal to, so k, instead of 1 divided by 4 pi epsilon naught, I am considering as k into, instead of q1 q2, here it is q1 q0 divided by, instead of r square, r1 square. I hope everyone is clear. Plus k into q2 q0 divided by r2 square plus k into q3 q0 divided by r3 square. So this is a way to find a force on q0 charge because of the rest of the charge, that is q1 and q2 and q3. It is added vectorially, that you must remember. Okay, so let us moving on to the, let us continue solving problems using superposition principle. Yes, here the first problem we have here is, they have given a square, and the square which has a vertices a, b, c, d, and a q, q, q. The positive q charge is placed on the vertices of the square. Now I am placing a q0 charge at the center. Okay. Now find a force on q0. This is our task. How to find? It is very easy problem. By the symmetry only you can see the forces on, the force on this q0 charge is 0. How means I have told before only, if both the charges are positive, then it will be repulsive nature. It shows the repulsive nature. Same for forces. The forces acting on the like charges will be repulsive, and the forces acting on the unlike charges will be attractive. So if we consider my q0 to be a center, the forces on this q the forces on the q naught because of q, it will be repulsive because q and q naught both are positive only, so it is repulsive. It will be this way. So the forces on q naught because of q, it will be this way. It is also repulsive, right? The forces on q naught because of this q, so it is again repulsive. And the forces on q because of the forces on q naught because of this q, so again it is also repulsive. So the effect, it will, it will be opposite to each other and it will cancel out, right? You can easily see here from the diagram, the forces will be opposite to each other and the forces will cancel out through the diagonal one, and the here also the forces will cancel out through the diagonal 2 from the superposition principle. So I can easily say the force on q naught which is equal to 0. Okay, otherwise you can find the forces separately and you can add all the forces acting on this q naught. You can do it. If you do that way also, that will be very lengthy, and this is the easiest one. If you do that way also, you will get the answer to be equal to 0 because force has even the magnitude as well as the direction. Here you must consider the direction as well. And I told, if it is a repulsive means, if the charges are repulsive means the force will also repulse. If the charges are attractive means the force will also attract each other. Okay, so from this symmetry I can tell a force on q naught which is equal to 0. Now let us move on to the next problem. In the next problem, what they have given, the same question. Here only change is instead of plus q they have placed the minus q. Okay, let us solve this problem. So you can solve this problem using the superposition principle only. Like you can find the charges because of q naught on all the four charges separately and then add them. You will get the final answer. The one more way you can do is, instead of minus q, what charge should I place so that the effect will cancel? Means we call this method to be cause effect method, or the superposition principle only you can call. So I have considered two such squares. So instead of this minus q, one time I'll keep it as plus q, and one more time I'll keep it as minus 2q. So minus 2q plus q is again minus q. You will get the same minus q only. So rest of the vertices are occupied by the positive charge. For this also, rest of the vertices are occupied by the positive charge. So at the center again we have a q naught. Here also at the center again we have a q naught, right? So everyone is clear. Now what I want to find, I want to find a force on q naught because of all these charges. From the above example only it is clear. The force on q naught is 0 because of this case. I'm splitting into two cases, so let us consider this is a case 1 plus sum of case 1 and case 2. You will get the overall this answer, right? So according to the case 1, what happens? The force on q naught which is equal to 0 because of the symmetry or using the superposition principle. So instead of here what we have, minus 2q you have, so you need to consider this minus 2q only, then you need to calculate the force. Rest of the force no need to worry. Okay, rest of the sides no need to worry, only this side you need to worry. So here what is the distance you must find? If I consider a side which is having to be the value a, so if I will found out the diagonal value. So the diagonal value is found out by using the right angle triangle. It will be a square plus a square. It will be 2 times of a square. So a square root of this, so it will be square root of 2 into a divided by half. So the value of this will be a divided by square root of 2. Okay, so the value of this will be a divided by square root of 2. Now how I can find the force? I can find the force to be equal to F, which is equal to K into what we have here, K into Q naught minus 2 Q naught. So it will be Q naught. So I'll take only magnitude. Uh, Q naught and 2 2Q, it is only not Q naught, it is only 2Q all divided by the distance square, this distance square, that is A divided by square root of 2 whole square. So it will be A divided by square root of 2 whole square. On simplifying, we'll get force which is equal to 2 times of K into Q naught Q divided by A square into square root of 2 whole square. It will be divided by 2, right? If it goes upside, so force which is equal to 4K Q naught Q divided by A square is the force on the Q naught charge. So I hope everyone is clear. So the like this kind of examples, it is very easy to solve using this method. So what we did, we have separately taken, one time we have taken the a charge to be plus q, and one more time we have taken the charge to be minus 2q. So minus 2q plus q, again it will give minus q only. So due to symmetry, the force on q naught will be 0 because of the case 1, and case 2 only we need to concentrate between these two only. If I solve for this, I got the answer to be equal to F, which is F of q naught, which is equal to 4K q naught q divided by A square. Like this you can solve many problems. So instead of q naught, if they place no charge, if it is 0 also you can find. Instead of here also, if they place minus 3q also you can find. So if you understand one problem, you can easily found out the rest of the problems. Similarly, we shall move for next. They have given the pentagon picture, and vertices, it is occupied by the positive charges q q q, and in the mid q naught we have. So you, by the symmetry, I can tell the forces will get cancelled. The force on q naught will be 0. By the symmetry, it is clearly seen the force on q naught which is equal to 0. Okay, now the next problem is all four sides, it is filled with a positive charge q, that is all vertices. Here the charge is 0. Okay, so here the charge is plus q naught. Here the charges we have considered plus q naught. Let me write it properly, q naught. Now I want to find the force on q naught because of all these charges. So first what I can do, so using the same previous method, that is a cause effect. Okay, so we will separately deal as a two cases, that is case 1 and a case 2. Instead of this 0, what I can write, so that it will be 0, once time I can write it as positive q, one more time I can write it as negative of q, right? Positive q, negative q, it will be again 0. So here I can fill the vertices to be q q q, and in the mid it is q naught, and here q and here q. Here one more time I can fill it as minus q. The rest of the things remains same. Okay, here it will be q, here it will be q, here it will be q, here it will be q. Only we need to concentrate on this only, not rest of the things. Where the rest of the things we have done here itself. Right, now how to solve this problem? It is very easy. So by the symmetry, the force on q naught because of this case 1 which is equal to 0. Now if I consider the distance between the q naught and the minus q to be a, the force on q naught because of minus q will be F, which is equal to k q naught q divided by distance square, that is a square. This is the answer, the force on q naught. Right, I hope it is very clear. Instead of if I keep for 0, if I keep minus q also, you know how to do. If I keep plus 2q also, you know how to do. If I keep minus 2q also, you are able to do. Right. Yes, I hope everyone is clear. Now let us move on to the next problem. Try this problem by yourself, and if you find the answer for this problem, do comment in the comment section. Thank you for watching. For more videos, you can visit my YouTube channel, that is Physics Unwrapped.